Howdy guys, this is going to be covering topic 2-4, graphing a function rule. We covered on September 17th, 2015, which was a Thursday. Alright, so here we go. We will be able to graph equations that represent functions. Real simple, guys. Alright, solve it, no, I don't need that. No vocabulary, no essential understanding. The set of all solutions of an equation forms the equation's graph. A graph may include solutions that do not appear in a table. A real-world graph should only show points that make sense in a given situation. Okay, so we have continuous graph, which is a straight line, guys. Don't forget, straight line. Straight, straight, straight. This is not a straight line, but a continuous line. So that's also continuous because it's unbroken. Okay. But here we have a discrete graph. You have it broken up. Okay, so it's broken up. It's not straight. That's not continuous. Let's see, so a step function is also non-discrete. So pretty much anything that's broken. So anything that is broken, and a continuous is anything that is unbroken. Okay, problem 1, graphing a function rule. What is the graph of the function rule y equals negative 2x plus 1? So pretty much what we do first, we have to make a table. So let's go ahead and put a table on here. So we have our input column, our work column, and our output column. And you can choose any random numbers you want for the input. So I'm going to go ahead and choose negative 2, negative 1, 0, 1, and 2 for the input. You can choose whatever you want, 0, 1, 2, 3, 4 if you want. So now let's go ahead and plug in. So negative 2 times negative 2 plus 1 is 4 plus 1, which is 5. Negative 2 times negative 1 is 2 plus 1 is 3. Negative 2 times 0 is 0 plus 1 is 1. Negative 2 times 1 is negative 1 plus 1 is negative 1. Negative 2 plus 1 is negative 1. And then negative 2 times 2 is negative 4 plus 1 is negative 3. So we have our 5 points. We have negative 2, 5, negative 1, 3, 0, 1, 1, negative 1, 2, and negative 3. So let's go ahead and plot those points. First, we need to put the increments on our x-axis and our y-axis. So let's go with 1, 2, 3, oops, too far. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. And 1, 2, oops, 2, 3, 4, negative 5, negative 5, and that's positive 5. Okay, so now let's go ahead and plot them. So negative 2, 5, negative 2, 5 is way up here. Remember, you run before you jump. You go x, which is left and right first, and then y, which is up and down. And then negative 1, 3. So negative 1, 3. So left 1, up 3. 0, 1 is you don't go left or right, but you go up 1. 1, negative 1. So right 1, down 1. And lastly, 2, negative 3. So right 2, down 3. So then there is a straight line. It is continuous because we have a function here. And there's no limitations to it. There's no real world situation to deal with. So it's going to be a linear continuous. Here we go. Problem 2. Graphing a real world function rule. Now this one's a little different because whenever you have real world situations, there's limitations on your input. Okay, so let's go ahead and read this. Trucking. The function rule W equals 146C plus 30,000 represents the total weight W in pounds of a concrete mixer truck that carries C cubic feet of concrete. If the capacity of the truck is about 200 feet cubed, what is a reasonable graph of the function rule? Okay, so we need some important information like our equation and this limitation right here. Now this limitation says the capacity of the truck is about 200 feet cubed, meaning if you have a truck and your output is the weight, so we're dealing with weight, and the capacity of the truck is about 200 feet cubed, that means your truck can only carry 200 cubic feet of concrete. So that means your truck can only weigh a certain amount for the output, because you only have a 200 max input. So if we create our table, so we have our input, which is C, and we have our work, which is 146 times C plus 30,000, and then our output, W, our max input for our equation is going to have to be 200. We can't go over that because it says the capacity of the truck is 200. So also, we're dealing with a real world situation. In real world situations, your input usually always starts at 0. And especially with this one, because we're dealing with concrete. We can't have negative concrete, can we? So 0 is your starting amount, 200 is your ending amount. Let's go ahead and go increments of 50. So 0, 50, 100, 150, 200 as our inputs. Now we can go ahead and figure out our outputs. So go ahead and plug in. So 146 times 0 plus 30,000 is 30,000. And then plug in 50. 146 times 50 plus 30,000. Let's see, 146 times 50 is 7,300. Yeah, 7,300. So we're going to add 7,300 to 30,000. So that's going to be 37,300. Now I'll go ahead, plug in 100. So 146 times 100 plus 30,000. Now we went up by 50 again. So pretty much all we're doing is going to add another 50. So add 7,300 pounds to our current weight. So it's 37,300 plus 7,300 is 44,600. So 146 times 150 plus 30,000. So that'll be 51,900 because we're just adding another 7,300. And then 146 times 200. That'll be 59,200. Okay, so those are the 5 points. 0, 30,000, 50, 37,300, 100, 44,600, 150, 51,900, 200, 59,200. So let's go ahead and plot those. But first we're going to make our increments on our x and y axis. So we have 0 to 200. So we'll have that's 0, and then 50, 100, 150, 200. Let's spread those out a little bit. 50, 100, 150, well, a little better. Okay, and now the outputs, which starts at 30,000. That's a lot. So let's go ahead and jump. And to jump on to jump to a larger number on a output axis, we have to put a little squiggly here. It's an ugly squiggly, whatever. I don't know the real term, but you put a little squiggly line here, and you can jump to any number you want. So from 0, I'm going to jump all the way to 30,000. And then our largest number is about 59,200, so I'm going to say 60,000 is going to be the largest. So 60,000. And in between that, we'll have 40 and 50,000. Okay, there we go. So let's go ahead and plot the points. So our first point is 0, 30,000. So 0 doesn't go left to right, but it goes up to 30,000. And then, oh wait, yeah, this is going to be 50, 100, 150, 200. Okay. Next point is 50, 37,300. So between 30,000 and 40,000 is 35,000. In between 35 and 40 is 37,500. So approximately that'll be right here, 50, and then 37,300. Then 100, 44,600, which is about 45, right? So we can just say right there, in between 40 and 50. And then 150, 51,900. So I'm going to say like right there. And lastly, 259.2. So right approximately there. Now before you draw your line, what do you think about this? Will our line be continuous? Will it go always left and always and forever left and forever right? I'm going to go ahead and say no, because we're dealing with a real world situation. Our truck cannot have negative pounds, so it can't go forever left. And also our truck can't have anything over 200, so it can't go forever right. So what's going to happen, we're just going to connect these dots together, and that's it. So there's your graph. Alright, so yeah, it's going to be linear and non-continuous. Okay, last problem, problem 3. Identify continuous and discrete graphs. So here we go. A local cheesemaker is making cheddar cheese to sell at a farmer's market. The amount of milk used to make the cheese and the price at which he sells the cheese are shown. Write a function for each situation. Graph each function. Is the graph continuous or discrete? So here we go. We have 1 gallon of milk is 16 ounces of cheddar cheese, and we have cheddar cheese wheel is $9. So we need to make 2 situations, so 2 equations from these 2 situations, and then graph them. So this first one, 1 gallon of milk makes 16 ounces of cheese. So I would say our input, and then our output is weight. So let's go ahead and say W for weight, ounces of cheese, and then say G for input, gallons of milk. So we're always going to start with our output. So output equals, so W equals, and then our input variable. How many ounces of cheese is made from 1 gallon of milk? 16, right? It says it right here, 16. So we're going to have W equals 16 times G. Because you have 1 gallon of milk times 16 gives you 16 ounces of cheese. If you have 2 gallons of milk, you'll do 2 times 16, which is 32 ounces of cheese. Okay, so this is our equation for this one. Now our next situation is the cheddar cheese wheel for $9. So we're dealing with money, and money is always output. So A equals amounts, so amount of money made from the cheese. And let's see, N is the number of cheese wheels sold. Number of cheese wheels sold. So we're always going to start with our output. So A equals some sort of manipulation of N. Now, how much per cheese wheel is it? $9. So you'll have A equals 9N. So those are the 2 variables. The 2 equations for our situations. So let's go ahead and go to the next page, and we're going to go ahead and graph these now. So we have our 2 equations, W equals 16G, and A equals 9N. And before we graph them, we need our tables. So you have your input column, your work column, and your output column. Now with the milk, gallons of milk, you can use any increment of milk you want. You can use half a gallon, a quarter gallon, 50 million gallons. It doesn't matter, okay, to make any amount of cheese you want. So let's say that we start with 0, because we obviously can't have negative gallons of milk. Let's say 0.5, 1, 1.5, and 2. So let's go ahead and find the outputs. So plug in 0, so 16 times 0 is 0. Now 16 times 0.5 is 8. Half of 16 is 8. 16 times 1 is 16. 16 times 1.5 is 24. And lastly, 16 times 2 is 32. So there's that one. There's that table. Now we need the table for our money made. So number of cheese wheels. Now cheese wheels are a little different. Cheese wheels are covered in wax. Alright? And they're covered in wax so that air won't get into the cheese and mold it and make it moldy. So we can't sell half a wheel of cheese. We can only sell them whole. So 1 cheese wheel, 2 cheese wheels, 3 cheese wheels. So let's go ahead and say 0, 1, 2, 3, 4 as the input. So go ahead and plug those in. 9 times 0, 0. 9 times 1, 9. 9 times 2, 18. 9 times 3, 27. And 9 times 4 is 36. So now we can go ahead and graph these. So let's go ahead and draw your x and your y axis, or your input and your output axis. Your input is g, your output is w, and your corner is 0. So we need the increments for the input, which is 0, 1.5, 1, 1.5, and 2. So that's 0, 1.5, 1. I mean, that's 0.5, 1, 1.5, 2. And then our output, our largest number is 32. So I'm going to go ahead and round that up to 40. And that'll be your largest number on your y-axis. So that'll be 20, that'll be 30, and that'll be 10. Okay, so now let's go ahead and plot these. Our first point is 0, 0. So put a point at 0, 0. Let's see, 0.58 is about right here. 116 is about here. 1.524, maybe like right here. And 232. Sure. Okay, now before we connect them, let's see if we can connect them. Which we can, because like I said earlier, you can use any amount of milk to make any amount of cheese. So instead of negative, you can't go negative. So we're gonna go all the way and even have an arrow, because we can use 3 gallons of milk, but that's not shown on our table, on our graph. But you can use any amount. You can use a quarter gallon, you can use 0.75 gallon, okay? So any amount of milk you can use, so it's going to be continuous. Well, it's going to be, it's going to be continuous. And it's going to be linear. Okay, next you have your money made. So let's go ahead and draw your output axis and your input axis. Your input is N and your output is A. And this is going to be 0. The corner is usually always going to be 0. And your increments for your input is 1, 2, 3, 4. So let's go ahead and put that 1, 2, 3, 4. And your output, the largest number is 36. So again, let's go ahead and round it to 40. Good enough. Okay, here we go. So let's go ahead and plot the points. 0, 0 is your first point. 1, 9. 2, 18. 3, 27. And 4, 36. Now before we connect the dots, let's see if we can connect the dots. And we can't, because, like I said earlier, cheese wheels you have to sell whole. You can't cut them in half. Can't cut them in quarters. So you can only sell 1 cheese stick and make $9. And then 2 cheese wheels and make $18. So you cannot connect these. So this is going to be discrete. And it's also linear because it's going in the line. But yeah, that's all, folks. Thanks for watching. See y'all in class.